everyone. Do you hear me well? Yes? I'm very happy to welcome you tonight. This is our session 15 of Pi School of AI, and I'm very glad that you're all here. We are in these beautiful villas where we combine creativity, human touch with AI. So we have more than 65 investments in applied AI in startups all over the world. They are from Europe and also the US. We usually put from 50 to $500,000 in these startups. We used to be, we started as an incubator, the first incubator in the Lazio area. And then we moved to be a private venture. So today you are in Pi 6. We just released our new office, Pi 8, just nearby. These are all villas like that. We like to combine the beautiness of the place to work with human creativity and technology. How did we start Pi School? We were surrounded by investors coming to visit our startups, and they were all coming to us saying, hey, you do AI, apply to languages, you invest in startups applying AI, why don't you help us do something with AI? I have an idea, how can I do that? And on the other hand, we had engineers that we were lacking engineers in all the ecosystem, and we said, oh, there's an opportunity. So that's how we started Pi School, to combine these ideas that the company had with the willingness to improve people's skills in AI, and that's how it started, basically. So I'm gonna introduce you lots of very nice guests tonight. We have a special one. I want to leave the floor to Marco. Marco, you are here tonight. I'm very happy that you can take the floor. Do you want to introduce yourself and say some few words about maybe the last technology, the last technology that we released? Thank you.
Hello. If I knew it, I was wearing a jacket like this. Yeah. So again, welcome to Pi Campus, welcome to Pi School. It's truly a pleasure to have the pitch day tonight. I think Isabel wants me to introduce you also to Translated, which is kind of the mother of the school and the mother of Pi Campus. So it's a company we co-founded in 1999 with the idea of solving the language translation problem. And it started as a first e-commerce for professional translators. So you could drag and drop a document, and we will connect you to the best translator in the world. And the passion for AI started mostly because we didn't have money to hire people. And so we said, okay, how do we select the best translator in the world? And in 1999, typically you have to hire people, recruiting, and read many resumes, etc. Instead, we said, okay, we do it a little bit, and then we train a model to predict, given the resume of a person, how probable is that you are a good translator or not. And believe it or not, it was a very easy task. We were very surprised that, if you went to Cambridge University, for example, and if you have this certain software for doing translation, very probably you're a very high qualified translator. So the machine showed a lot of good results, and we were very happy about it. And so we started moving to automate every part of the process so that buying translation was becoming easier. And then we start tackling the biggest problem. The one that is very hard is that, how can we make professional translators more creative and more productive? So how can they translate way more? And so the idea is that you give AI a suggestion, a translation already done, and they can edit the errors. And as you edit the errors, you collect this incredible data, which is the negative example, so what the machine did wrong, but also what was corrected by the translator. And as an extra proxy, we started collecting the time to edit, the amount of time translators were taking in order to correct this. And so we had a measure of the complexity or how wrong was the suggestion, not based on edit distance, so how many characters you changed, but actually how much cognitive effort you made. Obviously, we discovered certain times that translators were taking 5 minutes to do 10 minutes to do a translation, and we discovered that was not very complex. Simply, sometimes they have to go to the toilet, okay? But no, we were able to filter out those things and created a model. And so translators have started collecting this data, and you know what? After you collect so much data, people start getting interested in this data. So for 15 years, we have sold about 10% of our data to a company called Google to create something called Google Translate that you all know, I think, and all use. We had this premium data because not only we had sentences translated, we have the negative example, but we also have the context information. But at that time, context was not very useful because machines were not able to process context. And so after many years, we started building our own systems, not only for supporting translators, but I said, why don't we give this also to an end user, to a company? And so we released openly our models, and companies started going from Google Translate and Microsoft to us. And Google didn't like it, and we canceled the contract we had, so we didn't give the money, the data to them. They're not giving us certain other works, but we happily started to compete. Okay, and then I'm done. What Isa wants me to tell you about is our newest model that we have just done. And so for many years, we worked in this field called machine translation, which is, by the way, I think is the mother of all the AIs. If you think Turing, when the computer invented Enigma, the first application of a computer was actually not translating a language. It was an artificial language, but it was a language. So all the big invention in AI, most of them were done for solving the translation problem. And even in this room, exactly where I'm sitting here, one of the very first, if not the first public presentation of the transformer was done here. So Lukas Kaiser, one of the author of the paper and also one of the other advisor of the school, they wrote the paper in 2017, in June, and a few months after, he was talking about this new incredible algorithm, the transformer, generative pre-trained transformer, GPT, ChatGPT is what it's based on. And that algo was built to do translations, transforming between languages. And so we worked on that field for many years. And then there was this other field, there was language models. There was, a service to us. If you were building a machine translation system, you will need a small language model to predict what is the right sequences of words. If you were doing speech recognition, same thing, etc. So it was kind of a side tool, was not the big thing. But then, with the transformer and with the amount of computation, etc., there was some emerging properties that were coming with the transformer. And so you can create these bigger models, and they start not only predicting the next word, but it looks like that they're doing some more complex things that may look like, or probably, or maybe is, intelligence. And so very recently, 6th of February, so a few days ago in Paris, we just released our new very big model, which is a combination of a language model and a translation model combined. And so it's a new architecture that takes the fluency of a language model, so you get trained on trillions of words like a language model, but we also add the component of a translation system. So it's highly constrained language model so that it does not make the hallucination that a language model makes. So machine translation before was, kind of correct, but very literal. Language model were fluent, but absolutely hallucinate and wrong. And now with this architecture, basically we have this new technology, which is very interesting. And I think you can try it. It's for free. Now this time we decided to release it to the public. So at laratranslate.com, Lara the translator, you can find it. And one thing that this model also does, which is quite unique, is that it's able to explain the reason why it did translate in one way or another. So if you translate a little text, you will have a little pop-up down that tells you why the system has picked one term over the other and the different options that the system has evaluated before outputting. And you know the magic? If there is ambiguity in your content, and so the translation is not clear what it should be, it will ask for clarification. So it's asked to interact with you to try to decode that. So there is a text translator, document translator, and also a voice translator that we released it in an experimental way. It's very fast, it's very interesting, but also has got some interesting characteristics that would be my last point here, is that we discovered that the bigger the model you make, the bigger is the intelligence, the hardest is to make the model work for you. So this system is an interpreter. You start interpreting, it will interpret, but after a while, if your conversation is very interesting, it will forget she's an interpreter, and she will start discussing with you about the topic instead of doing the interpretation. So I think we will solve it, and that's why we put experimental big written there so that we lower the expectation on the tool. But if you use it, you will see it's extremely fast, extremely powerful, so very interesting. So thank you for inviting me, and it's my job to introduce, I think, the guest for tonight, which is a pillar of the school, because when we started PySchool in 2017, there was only a small group of people. And actually, Europeans that many of them were living in the United States. But no, in 2017, we kind of noticed that AI was becoming big. After working many years there, nobody cared. Now it's becoming super big. And so in 2017, we realized that we needed more people trained in artificial intelligence. And so this person, together with a few other friends, we have helped up setting up the schools today. And he's a pioneer of artificial intelligence. He invented one of the techniques I think in 1984, 87, time-delayed neural networks that are the basis of convolutional neural net. So is the early version of it. And then has done an incredible career in speech and coordinating some of the largest research group. Today he's a professor at Karlsruhe University and the Carnegie Mellon. And I want to welcome, with a big applause, Alex Weibel. And Sébastien Gratier, which will introduce himself.
Thank you. No problem. No problem, Marco. So it will be my pleasure to interview Alex for you. I ask a couple of questions to get the conversation flowing, and then hand over to the floor for a couple more questions. All right. So thanks, Marco, for doing Alex's intro. Alex is really a character in the landscape of AI, and especially speech and the world of translation. Maybe a couple of you guys here might know that Alex is the founder of maybe the most important conference in speech translation, which is called IWSLT, which is the International Workshop on Spoken Language Translation, which was born out of one of the projects that Alex worked on. I think some of you might also know that Alex, apart from being an amazing scientist, like Marco said, he founded so many startups, mostly spin-offs from his own research. 13, that's the count. The latest was sold to Zoom. One before, a while ago, Jibigo, that had as product Jibigo, that was sold to Facebook. And so Alex ended up founding the language technology group inside Facebook. And this was a while back, even before AI was such a hot topic, even in Facebook. And so we have Alex here with us tonight, and given your experience, this kind of pattern, this repeat thing that you've done time and again, like research and putting out some research results and putting them into shaping them in the form of a company, of a product, and then moving on, that way and doing this pendulum essentially between academia and industry in the form of startups repeatedly. So based on all this experience, I wanted to ask you a couple of questions and maybe, take from what I can suspect that many of the young people here might wonder about. So my first question to you would be, what do you see that people with a scientific background do wrong when they become entrepreneurs, essentially, which is obviously tech transfers. This is what it is. What do people get wrong when they try and do this?
Well, just allow me to just say a few words before I answer your question, to simply thank you, first of all, to come here. I just love coming here and visiting here and meeting everyone. And all my discussions with Marco and you are just always so delightful. And the question is why? Because we share sort of dreams about technical, scientific advances, but also turning them into something that goes into the real world. And I find Marco's vision for these things just totally impressive, because it means taking big risks. Risk-taking is one of those things that we share. We just love doing crazy things. But it's at the heart of it. If you look at the world and saying, I really want to have some impact and do something, then it's not enough to just have a technical vision, but you have to have the will to really turn it into something that people can really touch and feel and use. And that is so essentially already the beginning of the answer to your question is most scientists at the university, they don't go that far. They just simply say, well, I just want to do cool stuff. And where's the database that I can train it on, right? So I tell them at my own lab, well, it's just like if you're doing research and you want to conquer new worlds, right? You can't expect a nicely paved highway to the land that you want to visit, right? You really have to somehow go out there with a machete and create a path to it. And in our world, that means creating the databases, creating the infrastructure, doing a lot of dirty work that needs to be done to actually get there. So that's one of the things. How do you do that? How are you willing to really go the extra mile to do that? So it starts with the will to really want to do it. So for me personally, why did I do 13 companies? It wasn't really because, it's not that money is unimportant, but that wasn't the primary motivator. It was really more to say, I'm unsatisfied to just simply publish a new research thing. We started that way. I published a lot of papers, and Marco so kindly introduced this. And so, yes, there is the interest and the desire to really come up with scientific ideas. What's wrong? Why does it not work? How can we do this better? But then just publishing paper, putting it in some library and hoping that somebody will read your paper turns into a beauty contest where you essentially just, I have a better paper than you do. And I just got so disgusted and bored with it that I said, it would be so much nicer if people would actually touch it and hold it in their hand and really do something, and I can answer some problems. And so we started companies very often just as a way of doing things that you can't do very well at the university. At the university, we have to do master's thesis and PhD thesis, and so students want to do that, but they tend not to want to get out the machete and create a path to glory, so to speak. And that's, for example, what Translated is just such a wonderful example of, right? It's just not a company that only does MT algorithm. It's a company that does the MT algorithm and then fixes it so that in the end, there is really a perfect translation or a good translation that somebody wants. And that's my first lesson or my first answer to your question. The customer doesn't give a shit about your technology, right? They want to have some solution to a problem they have. I have a text, my website, right? Or my resume. Do I send this to some kind of your translator, your favorite translator, and hope that it's okay in another language? No, I mean, you want to make sure it's good quality. You want to make sure you represent your company well, etc. So you find somebody, can you look this over and see if it's okay? Can you fix it up for me, right? So that's the solution that somebody looks for. And so Translator does that. It goes the extra mile, provides the quality and delivers to you, to your doorstep, what you want, right? And that's important. Many scientists, as a scientist, very often we're too lazy to this, or we don't really want to go the extra mile. That's the difference to doing a company, because now suddenly you have to deal with real people and what they actually really want. And in one of the companies that I think the company number 9 or 10 that we sold to Facebook, one of our team members, he one time took me by the side and says, Alex, doing a company was really fun until we had customers. Because, now the customers have sort of things that they want, etc. And then I could tell many war stories where something wouldn't work. And I will tell one, maybe. I'm not sure if I told you this story, but when we built Jibigo, it was the first speech translator on the phone, right? So suddenly there were these people complaining that it didn't translate. Your system doesn't translate. Very bad reviews, And so I said, well, can you send us your file? Can you send so we can debug it and look at it, right? Well, we get back a file that is 20 milliseconds long. 20 milliseconds, there's no speech in there. So what happened is they just touched the button and let it go, and then they spoke, and the thing wasn't recording anything, and it was also, of course, not translating anything, and nothing came out. And so their analysis was the translator didn't work. It had nothing to do with translation. It had something with them not understanding how to push the button, right? So what do? You go to your scientist and say, read the fucking manual, right? The manual says you should hold the button until you recorded it, right? And I said, no. You're in a company now, right? You're not blaming the customer for not understanding what they should be doing, right? You fix it in such a way that they can step over it, that they can make that mistake, right? They have to somehow make it self-explanatory and easy. And that's of course hard for us, because now you have to come up with algorithms that notice that they didn't record. Either you have a pop-up or you just continue recording, etc. And there are many stories like this where normal people, what I always say also to people is, imagine, nothing against grandmothers, but I say, imagine your grandmother would have to use it, right? Would she want to use the stuff that you're building, right? And if the answer is no, you better kind of make sure it's better. So, and that immediately leads you to another thing, that it's not just the translation technology and the speech recognition technology. Again, I say speech recognition and translation. A lot of the work we've done is speech translation, right? Spoken language translation. And so most people in our field obsess over word error rates and translation accuracies. And I say, well, that's just important. But, 1% better or worse, you won't even notice. But if your interface is built in such a way that you can't use it, then the whole thing is useless, right? So the interface, how you capture the customer, how you bring it to them, etc., is really, really key. So again, the goal should be in the companies is to do a good business and not just impress people with your cool technology, because that just doesn't work in the business. And you should not assume that your customers are technical experts. That's another thing that scientists get wrong. They always, my students, I tell them, say, even when we process data and label data, right, don't assume that your labelers and your people process are computer science experts, right? And it's very, very difficult for scientists to explain it to normal human beings and to get normal human beings involved to use it, right? Very hard. And so there's a real learning curve for scientists to do this. Don't blame the customer, I mentioned that already. Then, of course, young entrepreneurs, when they go in, cash is oxygen. You need the cash to survive. At the same time, and I say maybe a little later on this, is don't gorge on VC rounds. That's usually a mistake also. Now the other way around for managers, oftentimes people think you can manage a tech company without any technical understanding. All you need is somehow, have an MBA in something. That also doesn't work. If you look around, the best high-tech people in the industry, I will not name any names because it gets quickly political, as you might imagine. But many of the really top people we admire in tech are deeply technical people who also understand customer needs and also understand what you need to do to make it work. And so it's really the best people who do it understand both. So you can't manage. A famous Grace Hopper, the famous admiral, she always says, you can't manage people into battle. You have to lead them into battle. And modern technology is battle, right? It's very fast moving, and so you need to be able to do that. I think that probably overdid my first answer already.
Well, that's amazing because thank you, Alex. This is so valuable. I think you're distilling years and years of trials and attempts and adventures and war stories in a couple of words here. I imagine this is really valuable to us. Let's carry on, and then something that I'm curious about is like this thinking in terms of patterns, namely, if there are any, I'm not asking for recipes, but to get that right, to get technology transfer right, have you observed that, well, maybe yourself or others have done things that you can kind of identify and say, doing it this way works, versus what we've discussed now, which is the anti-pattern, like doing or trying this doesn't work, and this is kind of a usual bias, a usual mistake. If we take the positive, what comes to mind?
Yeah, well, I guess it's also war stories, right? I mean, many of the things is how do you build. Actually, I'm not sure if it's the top reason or the second top reason, but it's actually a real statistic. Why startup companies fail is that the founders start fighting with each other, right? So not getting along with your other people is a killer for a company. Why? Because if you start a company with 3-4 people, everybody does 5 jobs, right? You have to do finance and marketing and things, and everybody does 5 things at the same time. That is the beauty of it. I mean, that is why I love doing it, right? Because you can now, with a small team of people, really change the world. You don't sit around in meetings all day long like the big companies do, where everybody has a tiny slice of the business, and they have to spend all their time in meetings explaining things to each other, etc., to get anything moving. Here you can just move on a dime and do things really, really quickly. But you better understand and love your peers, the people with you, and get along with them, because if anybody somehow doesn't work well with each other, then the whole company goes down the tubes. And so, for example, and why do people fight? Well, it's personality conflicts, it's egos, it's money, there are many things you need to kind of really get right and make sure that the team remains happy and working with each other well. And in setting up a company, it's critical to select people who are just basically nice people. So if you give me the choice between someone who is intelligent and super nice or somebody who's a genius and not nice, I will pick the nice person that's intelligent anytime. In fact, there's a crude way of putting this from Sir Richard Branson from Virgin Galactic, or Virgin Atlantic, who was asked that question, and he says, it's better to have a hole in your team than an asshole in your team. And I completely subscribe to this, right? So one person can really poison the climate, and then the whole company doesn't really work. So pick really, really good people who are also nice people to get along with. And I think that is just a crucial thing that I made as a habit. So now, of course, as a university professor, I have the luxury that I get to know people really, really well. So very often we start companies out of the university where we figure this is really an interesting product we can do, but then you pick the people that can really do that, that have a practical tilt, that are nice people, that are super intelligent, who don't mind kind of doing the work that is necessary, and then you gradually build a team. Now that's a bit a luxury, of course, being an academic, but still I would recommend or give this as an advice to do it this way. You asked also how does the transition work? Of course, when we start with something in science, I think the first thing you have to ask your question is, would somebody really pay money for this, right? I mean, very often we have really cool things that are really wonderful, but you wouldn't build a business around it. It's just a cool idea. Or there is no market, and I could, again, tell you many war stories of friends of mine who decided they want to do a business around something. In fact, we did the same mistake. Okay, I will tell one. Before we did Jibigo, we built the world's first sign translator. So it was you hold up the camera in a road sign in China, and it gives you the translation into English, right? We built the first one, and we published the first paper on this, right? Now, of course, you can find it on Google, and in fact, long story, I know the people, etc. But the thing is, at the time, there was no iPhone. You could only get a compact iPad, these PDAs, right? I don't know if you are all young people, you don't remember what a PDA was, but it was it was this thing you bought and you did your calendars on it. And now you could buy an extension camera you could put on top of it, right, that attached to it to capture an image. And we had a wonderful system. You could point it at the Chinese road sign, it would recognize the OCR and translate it into English, and voila, you get the translation into English, right? Problem was, I don't know, only very few people had PDAs. And now you have to have people who have a PDA and are buying an extension camera that you put on top of it. And then you have to go to China and have the problem of translating into English. So the market was probably, the intersection of the market was 0 or 2 or something like this. And so we said, this is a classic example, really cool technology, but not a good business. So we pivoted to the much harder problem, really, which was the speech translation, where we could really see a market of much larger thing, and that was the beginning of our development of Jibigo, where we ended up selling it over the iTunes iTunes store, and that was coming along at the time, and the iPhone was getting powerful enough, and you could speak into it, and suddenly we really had a product that people bought and liked, and Apple made commercials with it, and so it became a big hit, and eventually Facebook bought the company. Did I answer your question? Great. So, one important thing I wanted to also say, your business also, the way I did my businesses were almost always a gradual transition. So we have a cool idea, we build a team, and we gradually transition. So that means financially it was most of the time bootstrap. We hardly ever took large. We did take a little VC money, but not much. And the question is, do you have to do it this way? The answer is no. You can go the other route. You can go take VC money and grow and do it that way. And many startup companies do that. How do you choose how to do it? It really depends on the business and on the speed with which you must grow, right? If you're the next Facebook, and there are many other players who do social networks, and you want to dominate the market in the shortest possible time, you need a ton of money to grow as fast as you can and do it, and that's where VCs come in, right? But you have to always keep in mind, most young entrepreneurs think that having a large VC round is what you should be proudest of, right? So people say, so many tens or hundreds millions of dollars in VC money. Whenever I hear this, I feel sorry for the people because they become slaves in their own company, because now they have to answer to all the VCs and all the money people who provide this. And you reduce your options in the future. You have to now become the next Facebook, because very few people will pay you hundreds of millions of dollars to buy your company. It's because, again, in terms of an exit, it's either an IPO or an acquisition. And when a company grows really quick with lots of money, then an acquisition usually gets tougher to do or impossible, right? So again, think about whether you want to go into a gradual transition and a bootstrap operation, or whether you really must grow. It really depends on the product and the business you want to build.
Alex, should we take one or two questions from the floor at this point? What would you like to ask Alex? What's on your mind that you think he has his own answer to? Here's one.
Thank you for the talk. That was really insightful. I wanted to ask, in the age of AI, what do you think is better, first mover or improver? Because things are moving really fast.
Yeah, I was afraid a question like that would come because the world really, I mean, I have to say, many of the things we did, we had years to play with, to develop, right? I mean, machine translation, I spent most of my career, and now things are happening at such an incredible speed where where the technology can't be done by a small team anymore. You know, a lot of AI is now commoditized. You rent it, you buy it, right? And if you go to conferences, most of the papers are adapting something to something else. And so I think currently probably most businesses go into improving, because a lot of this is out there already. And when we talk about AI, again, way back in the earlier days, AI wasn't really defined in terms of a method, right? I mean, I was one of the early people who believed in neural nets, but at the time there was logic-based and rule-based and statistical-based, and nobody really knew how to do it. Now it's so ingrained, and you have all these tools that I think most of it is probably improving. Because, very few people can actually build an entire new model or a whole new method how to train and build these models, et cetera, at this very moment. This might change. I mean, maybe somebody comes up with a completely different technique again, but it's all we really know that it's happening at an incredibly fast pace. And so positioning this means also being quick with a small team and then addressing a need. So I would say probably most businesses go in direction of improving. But I mean, having a solution that improves on the techniques that are there. I mean, not sure it's a fair, because the next question he's going to ask me is, does that mean it's all done with AI? Should we just basically just tweak whatever OpenAI is doing? I would say no to that too. But in terms, you asked about businesses, and businesses obviously need to move really fast, and you don't have the luxury to make many mistakes on something.
Okay, thanks.
Is that
I believe it's yeah. Do we have another question from the floor? I see Cristiano has one, but Cristiano is from the team, so if anybody,
go ahead.
Easy, no? Okay, Cristiano it is.
So thank you. You've said that you have founded 13 companies, but to found a company, you must fall in love with it. So is it hard then to sell your own company?
Yes, it's hard because you enjoy it, but very often, well, first of all, you make money, right? And with that, and usually I have already a new idea. And if somebody gives me money so I can do the new idea, that is not a bad thing to happen. So you start over. But very often, as I said, at least in my case, and it's very different. I mean, I don't want to say that my path is normal necessarily, but very often we start with something that we just really enjoy and we think we can make a contribution, and then actually very naturally, we were just talking today about some of the speech translation things we're developing now. they're driven by actual need. We are running simultaneous interpretation systems at the university, and then we see. So eating your own dog food, that's one of those phrases. It's really important because you really see what works and doesn't work. And the best ideas we always develop when we actually see people using it and we see what works and what doesn't work. And if you then come up with a good solution, people automatically come and they say, oh, I would like that too. And we see that happening all the time. And then the question, is it easy to sell? Well, I mean, one of the pleasures is if you really do sell it, very often you get much, much larger exposure, right? So in a larger ecosystem, you play a role of transitioning something from science to really broad adoption. I mean, selling something to Facebook or to Zoom. I mean, Zoom, if you turn on the captioning, that comes from us. I mean, it's very satisfying to know that the whole world can now communicate over Zoom with our research, right? With our translation. And it couldn't have been done just by doing the science only. You really have to go the extra mile, see that it fits and that you have a solution, right? And then that is consolation for giving it away, basically, that you see that it has impact, and that's ultimately what it's all about.
Thank you so much, Alex. Thanks for being with us. Big round of applause for Alex, please. And at this point, I'd like to introduce our second guest for the evening, Nicolas Longépé, from the European Space Agency. And Nicolas is here to tell us about two projects that PySchool is running with the European Space Agency. Thank you, Nicolas.
So yeah, Nicolas Longépé, I'm with the European Space Agency, so ESA. So we are just staying a few kilometers from here. We are in Castiglione-Romagna in Frascati, which is also pretty nice as a place. And more specifically, I'm with the PhiLab. So PhiLab is kind of disruptive lab in ESA, and we are doing mostly Earth observation. So Earth observation, I mean, we are looking at, could be flood, could be volcano, it could be fire, it could be salinity of the water, sea surface, current, whatsoever. I mean, we measure everything from ground, also gravimetry, geometric fields, could be atmospheres as well, anything linked to the Earth system. So this is what we do more specifically at ESA and within the Earth Observation Program Directorate. We build that together with a large space integrator like Thales and Inel Space. We have also many industries helping us to build those satellites. And as you can imagine, I mean, those satellites are, I mean, they are acquiring terabytes of data every day. I mean, we have a bunch of data, multispectral, hyperspectral, highly dimensional data that arrive to a ground segment every day. It's massive data that we have to actually mine. And as you can imagine, AI is one of the solutions to tap into this database and extract some meaning from it. And at the PhiLab, we are mostly focusing on disruptive techniques. And as you can imagine, well, we are doing AI as well. Of course, mostly on computer vision tasks, because we have image that are image, and then we use mostly computer vision techniques. But we do have as well some direction in integrating like LLM, working on digital assistant so that you will ask questions to database and stuff like that. So this is kind of a prospect for us. And yeah. So together with PySchool, I mean, we are very happy because around Rome, I think, and also in Italy, and maybe in Europe, I think we found the best partner to work with this kind of topic, which is Eve, which is the Earth Virtual Expert. The idea is to build some kind of chat GPT for Earth observation and Earth science, because as you may have tried, I mean, any LLMs, general purpose LLM, are very good, generally speaking, but if you like a very accurate, scientifically valid response, well, it kind of works somehow, and it tends to hallucinate as well. So the idea of this project that we have with the team here is to work on that, is to provide to the community a tool that could be factual, accurate, that can be less prone for hallucination, and that can be really used by our community, which is Earth observation, Earth science scientists, let's say. So now the project has started actually in May last year. We will end up by the summer, whereby we'll have a pilot phase, whereby about 200 users will have access to our tool. It will be served with a graphical user interface and API as well. The idea is to fine-tune a model. I don't know exactly what will be the model that will fine-tune, but we selected a set of documentation that are very specific to Earth observation and Earth science. The idea is to continue the pre-training on this, and then serve it with different downstream tasks. Now we are thinking about Q&A, summarization, kind of domain extraction, stuff like that. Good thing is that, of course, we continue to mine open source documentation, which are all available. We made as well some agreement with some publishers, well, actually one publisher, to get access to one specific source of very accurate and nice peer-reviewed journal. So I guess that we'll come up with something which is very tangible for the community. The other project that we have as well with PySchool is this collaborative innovation network, which is kind of, well, at ESA, we always work a bit with what we call the usual suspects. So it's a bit like the community that we work with, and we want to expand our network. We want to attract any new investors. We want to attract new technological players. And the idea of this collaborative innovation network is really to federate those different ecosystems and aggregate them for us to work with the best in Europe and also worldwide. So we are very happy to work with PySchool on this project. So if you'd like to explore the different open cores that we have, because indeed we are looking for different, of course, senior researcher. We have as well some skills for hosting, visiting researchers also in the facility. So you have the different open schools that we have currently running. With that, just to say that also with PySchool, we have this event that will be held in Frascati early May, together with NASA. is about foundation model. I'm sure you have heard about foundation model, which are a big self-trained model. We used it a lot in Earth observation because we have problem of label. You need reference information for supervised training. So one way to get rid of this need for supervised training is to go in the direction of self-supervised learning and foundation model. So we have this workshop that will be organized in May, and actually PySchool will also help to organize some hands-on session, more specifically on the EV and the LLM that we'll provide to the community. And I think that's it. I don't know if I have more to, but yeah, that's it.
Thank you so much. So we have a partnership with LUIS, the business school in Rome, and I'm happy to announce that, well, we are now running, I think it's, the fourth run of this executive program called Managing AI that we have co-designed with LUIS. And so it's being taught in Italian. It's for managers, no tech background required. It's taught in presence at LUIS headquarters, not far from here. And the next session here starts on 27th of March. Anybody who's interested, you'll find the information on the LUIS website. And now I think this is for you, Cristiano. There you go. Over to Cristiano.
Thank you, Seb. It's this one too. Okay, hi to everybody. I'm Cristiano. I'm lead AI scientist at PySchool. I'm going basically to present you a little bit what PySchool of AI program is. So the reason why you are here today is because it's the pitch day, and during the pitch day, the team's fellows will pitch and present the challenges and work they have done in the last 8 weeks. So I'm giving a brief overview about the program and then go on with the pitches. So what is the PySchool of AI program? It's an intensive 8-week program that equips top scientists and engineers with advanced AI skills, and at the same time helps companies, startup, institutions to solve business problem, business pains with machine learning, more in general AI solution. Then I will give you some numbers about the PySchool of AI program, and in particular about session 15 later on. So this is the magic triangle of PySchool of AI. Isabel already explained it a little bit, but I would like to give you some more details. So on one side of the corner, there are companies, startup, that have business pain. You see, we discussed it earlier that tech is evolving super fast, and the market is also evolving super fast. So companies must, you see, to stay updated, and they need to solve their problem. So on one side, we have a company, startup with business pain. On the other corner, we have people, engineers, scientists, eager to learn and to work on AI projects. So our job is to, you see, select the best engineers and people that willing to work in AI, and you see, organize teams of these we call them fellows, and together, you see, in 8 weeks, solve the business the pain of the company. We call the company the sponsor of the program. And so how we do it, again, we build teams of fellows, and each team is coached and mentored by experts in the specific topic the company needs to solve the problem. And we use an agile and startup mindset, you see, starting from week 0 and then week by week improving till the end, you see. And so we deliver AI MVP solution, and at the same time, the program trains, you see, new people into with state-of-the-art skills into AI. This is the scientific advisory board. So behind the staff and the fellows and the program, there are super interesting people. And today you were lucky enough to have Alex with us, and there are others like from Amazon, I explain, Lukas Kaiser that was mentioned by Marco in his speech. Lukas Kaiser is the one of the 8 guys behind the Attention is All You Need paper that introduced the transformer architecture, and Riccardo Sabatini and others. And so this is the scientific advisory board. And I want to spend also some words about, you see, the companies we worked in the past and in the present, and sponsoring a challenge at the Pi School of AI program. It's really can be done by any company. Small company like startup, Brink is a Berlin startup working in AI and sustainability, but at the same time, not only small company, also very big company like Thales, and we have then Fabio from Thales that will spend some words. So you see, sponsoring a challenge is for small companies, big companies. Also for companies, we had companies that started their journey in AI with Pi School, and companies instead that are already in the tech ecosystem that spend time with us working on specific problems and maybe linked to the research. So you see, tech company, not tech company, small company, big companies can you see, partner with Pi School. I would like to give you some numbers. You see, last year we basically reached 100 challenges, and maybe after this session will be 110, and 4, okay, 104 of MVP prototype since the beginning. We had more than 230 fellows over the world that we select from universities like Cambridge, Mila Institute in Quebec, ETH Zurich, also from Italy, from Roma La Sapienza, from everywhere. And these guys are selected worldwide, and among many engineers, 2,050 engineers, and our selection rate on average is 10%. But now I would like to give you some number of this session, session 15. And in session 15, we had 4 different challenges, so 4 different companies sponsoring the program. And this company were coming from 4 different sectors, you see? And 11 fellows selected worldwide among more or less 300 candidates. So our selection rate this time was even lower than 10%, was around 5%. And 19 is the number of state-of-the-art recent research paper that were basically instrumental to our challenges that you will see in a while. Obviously, we read much more than this number, but 19 were exactly the paper we really, studied to develop what we have done. And 86% is the accuracy that was reached by one team on their challenge. And basically, this accuracy was much higher than the accuracy reached by Textract, which is a library from AWS, from Amazon, on a specific task in, I don't want to spoiler what, so you will see soon. So again, you see, these are the numbers of this session, and I don't want to spend more time. I will leave the floor to Marcello that will pitch. We will present you the first challenge. Thank you.
Thank you. Hello. So let me present myself. My name is Marcello Politi, and I'm one of the machine learning engineers here at PySchool, and one of the coaches of this challenge. I speak on behalf of the fellows that work on this challenge because they couldn't make it to Rome. They're in a galaxy far, far away somewhere. They didn't get their visa. So I will explain what we worked on, and the cool title is Applying Minimalism to Text Recognition. Whoa. So the problem that our sponsor has, and also I guess many people among you, is that at a certain point in our life, I mean, personally every day, we need to handle unstructured documents like PDF. You can think about invoices, legal contracts, rent, whatever. And we need to extract important information from this documentation. But here comes the challenge. So first of all, you need to, with tools that you can find, you need to read the entire document and not only the important information that you need. So you need to understand exactly where is the important spot where the information is, and extract it from the document. Now, this is an example. So let's think about this invoice. You have only a registration number that it's important for you. So I only need that, not the entire document. How can I do this? So we tried with the tools that people are currently using in companies mainly, which are OCR models. OCR models are machine learning models that are built to extract text from documents, images, and so on. But we saw that these kind of OCR models nowadays, they create more problems than solutions. So usually they create too much clutter. So you have a lot of text in the document, and they agglomerate all of it together and and provide this bunch of text that doesn't make sense most of the times. So manual work remains. So after the extraction, you have to give the output to a human that needs to clean it, filter it, and fix it, basically. The documents you have are always different. So you have different kind of layouts, and it is difficult for the model to understand how to extract the information from layout A, layout B, and use for all kind of this type of documents. And this brings to time and constraint. So if you need to fix what the model is not capable of doing, you need to pay humans, and this comes with a cost in terms of time and money. And you might have different kind of text in the document. For example, we have to to extract printed text or handwritten text. So what was our solution? Our solution was to build a pipeline that was split into different phases. First of all, let's build a model that is able to detect what are the important spots in the document. So for example, if you see here in the first invoices, I have some important information in some particular regions. So we built a region detection model. Then let's get one of these regions, only the important one, and use another model, the OCR model, to extract the actual text only from that spot. Let's go a little bit deeper into the models. For the first part, so the region detection, we used one of the state-of-the-art models called YOLO. Usually, you can use MOLO to detect objects in a picture, so like a dog, a bicycle, a tree, what is that? A truck. And we tweaked it a little bit. We fine-tuned to make it able to detect important spots within the document. And the second, for the OCR model, actually we had to split the work in 2 other phases, because we used one model called Paddle OCR for the printed text, and another model called Florence 2 for the handwritten text. So the Paddle OCR was pretty easy because we just took one of these models out of the shelf, used it, and it detected the printed text quite accurately. But for the handwritten text, it was really a problem, because when people write stuff, I don't know, they don't look at the document, they just write blinded. So the data was really bad, and the model wasn't able to understand any of it. So we trained this Florence 2 model, which is a visual foundation model, which means a model that basically can handle both visual input and text. And you can prompt the model to perform some particular task. So for example, do OCR, do object detection, do classification. We trained this Florence 2 model on more than 10,000 data, and we reached pretty good results. So to recap the solution, first, we built this pipeline. First, a retrieval model, so get the documentation we need. Extract the spots, the region detection. Then classify. It's in the spot that we have printed text or handwritten text. Depending on that, we're going to use Paddle OCR or Florence, then post-process if we need to fix something, and then we save it on the sponsor database. And these are the results. So by using the current tool that was used by the sponsor, so AWS Text Extract, we had an accuracy of 46% and average response time of 1.3 seconds. With our tailored pipeline, we reached an accuracy of the 86%, and the response time on average was 0.14 seconds, which is pretty cool, if you ask me. So we doubled the accuracy, and it was 10 times faster than the previous tool used by the sponsor. Okay, I will leave the floor now to one of the mentors that helped in developing this solution, which is Matteo from Humans. So, hi, Matteo.
So, thanks a lot. I'm Matteo Vulcrano. I'm a product lead at humans.tech. We mostly do digital products, so we thought to intertwine our digital product expertise with the cutting-edge research and technology developed by PySchool in order to bring to the real world, as Alexander was saying, this technology. So why is this problem important? We're just fetching something that was on a document. It seems kind of not that big of a deal because OCR has been around for 50 years. But this is really important because every single error that we make in each step of the pipeline right now, it creates more problems. We start with the service users. As Marcello said, they don't look at the paper. They just write down whatever they want. This is also a problem because not always everything is actually automatically brought into a system. There is a human behind it, and that is the really, really weird spot we're in. Without the digitalization without the complete digitalization, we have to create a bridge between the physical documents and the digital documents. So right now, the bridge is basically a person that types down whatever the first user wrote. So they might do an error as well, so this pollutes the data even more. And that creates a problem for the software engineer that has to create all weird if-edge cases that sometimes implement more bugs. So all the data is now completely destroyed, and the data scientist doesn't know where to look, because where is the problem? Where in these steps is actually the problem? So the solutions right now are basically way too general. We don't need a model that needs to know every single thing. We need to do little tasks, but in an excellent way. We need to have the perfect score on multiple tasks rather than one thing that does things in a mediocre way. So you can see it from this simple, let's pass me the term simple, because it was not that simple in these 8 weeks, believe me. With this pipeline, we managed to double the accuracy of a software that was developed by one of the greatest companies around right now. So what we can do when we look at this is that we can expand it even more. So we can have it either get printed text or handwritten text, but we can get even farther. We can get to the context of where the text is. Something that right now we can just do with digital documents. And we can also find out the relationships between the data, because sometimes when you see a diagram like this, you have to use a multimodal LLM with billions and billions of parameters, when what you need is actually a simple pipeline that does the job actually well, rather than using a lot of energy to do it with less accuracy, let's face it. So this kind of steps, this pipeline, is what can actually lead us to bridge that gap of digital and physical, because right now there is nothing like it. And as a sad proof of what bureaucracy can do, our team didn't actually manage to get here because someone in the meantime has done an error. So I would like to thank all 3 of our fellows that helped us create this model that achieved great results. So, I don't know who's next, so I'll just pass it to Cristiano.
We'll call Cristiana.
We have this, okay. So, good evening, everyone. I am Cristiana. I'll be presenting tonight on behalf of my team, which also includes Sandesh and Prakar. And together we've been working on a project about multimodal AI for satellite images. So, last week we were all in Rome, and we were planning something to do on the weekend. And since we're all passionate about trekking, we thought that it might be a cool idea to go climb Mount Vesuvius near Napoli. So, of course, we started preparing for that. First thing we did was checking the weather, because it was not worth going all the way to Napoli if we would have a rainy day, of course. We checked the navigation to understand how to get there exactly. We checked the terrain to see what kind of shoes we should bring with us. And finally, being the good engineers that we are, we wanted to be ready for the very worst-case scenario, that we get stuck on Mount Vesuvius for some reason. And so we made sure that we could call for help through emergency communication. So we had a really good plan. And actually, we did it. This is us on top of the Vesuvius. So we reached our goal. And all of our preparation was possible thanks to some services which rely on a technology that's invisible to us, but it's actually omnipresent around us. And these are satellites. Satellite images, specifically, maybe, are an extremely powerful source of information that can help for monitoring sea levels and climate change, for helping in disaster management, for supporting urban growth and infrastructure development, among the other applications, or in our case, simply bringing us to the top of the Vesuvius. So, as a matter of fact, the whole Earth observation industry has attracted increasing attention in the recent years, with more than 1,000 active satellites in the Earth observation field, hundreds of companies operating in many countries, and a global market size of $9.4 billion. So it's a very interesting field, but unfortunately it comes with quite some technical challenges. So, as also Nicolas was mentioning before, satellite images are very difficult to be analyzed because every satellite captures terabytes of images every day, a large portion of which might actually just contain clouds or water or sand, so there's not much information there. And it's very difficult to search through these massive amounts of data which are, again, available at an impressive rate. And there is also, there doesn't really exist a unified solution based on AI that can cover the range of all the possible applications of satellite images. So dealing with satellite images is very difficult. It takes a lot of time, a lot of effort, a lot of processing. What if, instead of having to go through all of this, we could just talk to a satellite in natural language and get exactly what we want? And this is exactly what our stakeholders, Thales Alenia Space, wanted us to find out. So, about our sponsor, Thales Alenia Space is a joint venture between the French company Thales and the Italian Leonardo. They're primarily active in the fields of aerospace, Earth observation, telecommunications, and space explorations. And working closely with them, we were able to identify 3 main use cases of AI applied to satellite images. First of which would be an image retrieval application. So let's say we want to retrieve all the images of airplanes at an airport from a certain database. Of course, we expect the relevant images to show up. Another application could just focus on a single image and compare it to a number of captions and understand how relevant each caption is to the input image, possibly with some probability measure to quantify the similarity. And taking this application one step further, we could focus just on the most relevant captions, pass them through a custom text generation model, and combine them into a comprehensive description for the input image. So this would be a third application for a caption generation use case. Now the question was how to implement these use cases, how to put them into practice. We started researching the existing literature and the state-of-the-art models are available out there, and we found out that the CLIP model is a very good opportunity for us to work with. So CLIP is a powerful multimodal model which can bridge the gap between images and text input data. CLIP stands for Contrastive Language Image Pre-training Model, but actually that's a boring definition. So let me just give you an example. If we take an input image, and it's actually my cat, and a set of text labels, we feed it to the model, and it can actually compute the similarity, return to us the similarity of each text label with respect to the input image. So this is very good for us. It's almost very close to what we're looking for, but not exactly what we're looking for. In fact, CLIP is a very powerful model, but it's very good at dealing with common objects, seeing from a normal perspective, like some of us would see it, which is not what we're interested in. We are dealing with satellite images. They are taken from a very different perspective. So the model needs to be able to recognize them through that specific perspective. So we need a model which is specialized in this task. How can we achieve that from the CLIP-based model? We perform fine-tuning. So we gather then preprocessed data sets of satellite images to which we attached a notion of objects seen from a satellite perspective. And we furtherly train the model with these instructions so that it could become specialized in recognizing objects in satellite images. So now this is the model we can use. This is what we were looking for. And what we did was we implemented a solution which includes a strategy for fine-tuning a CLIP-like model in a parameter-efficient way and incorporates it into a plug-and-play component, which can be just given an input image and some reference text captions, and directly output the most relevant text captions with respect to the content of the image. So how does this improve the current analytics workflow? What happens in the standard scenario is that a satellite acquires images. A technician have to go through those images and perform a number of tasks. And let's say that technicians can analyze 2,000 images in 8 hours, roughly. Okay, a very good technician can do this. Okay. What our model can do is it can spare the most tedious time, the most tedious part of the job, to the technician, performing the same kind of processing in the same number of images, just in 20 minutes actually, and then leave to the technician just a second-level review, possibly some manual adjustments, leading to much more refined result, and especially a drastic reduction in time. So we tried out and tested 3 different versions of CLIP-like models, 2 of which performed similarly with an accuracy of around 73–74%, and 1 of which performed better with an accuracy of 82%. which is a very good result because a more accurate model, it's a better model, it's a faster model, it's a model that can save us much more time. And time is actually crucial for a number of applications, especially when dealing with environmental disasters, where time really is the key factor and can make a significant difference. So this was mostly the core of our project. And all of this was possible thanks to the combined expertise of our team members. We have Sandesh, which is a deep learning researcher, Pragar, machine learning engineer, and I myself am a data scientist. So for any further questions or curiosities, please reach out to us during the networking event, and thank you for your attention.
Okay, thank you. Let me just share a few comments before leaving the floor to Fabio from Thales. So this challenge is really an example of how we work at the PySchool program. So we started really as a research challenge to explore possible solution using this model called CLIP that Cristiano told you. And so we studied several papers. We discovered other research groups that were working around the world on, building and improving CLIP models. And then thanks to several weekly feedback from Thales and Fabio team that were super useful, to narrow down exactly the task they were interested in, and focus our efforts on mainly two tasks, then in particular one, as Cristiano told you. So it's really was a very good example of interaction between PySchool and the sponsor. Talking weekly on a weekly basis to narrow down the challenge till the very end and the task. So I would like to congratulate the team. Was super good, and congratulate also the sponsor really, because it was super helpful interacting with you and your team and all the team. Okay, so thank you. Fabio will leave you the floor. Thank you.
Hello, everybody. It was really a pleasure for us to work with PySchool and with the team. Cristiano mentioned having a pain. Well, for us, the pain maybe at the beginning wasn't really the problem we addressed. The pain is really having time and the right skills and the focus to work on it, because we know how to do that. But working with this team was really great bang for the buck. In a very short time, they help us in framing the problem and then solving it. Of course, Cristiana had a slide saying, talking to a satellite. That's great. We are not there. We're not there yet. It will take some time before we have such a processing power on board a satellite to do that. But we wanted to see how to get there. And this is really where we had a great collaboration. I hope it will be something that continues. And we identified some use cases that really could be breakthrough. Alex mentioned before, just with nonchalance, no? By the time I sell a company, I already have another idea. So that's the point. Great minds have the idea. And I think this is today the challenge, because you find whatever AI solution you look for around, it's there. If you don't find it, look better. But having the idea of using it, what use case to tackle with it, that's the point. And the guys here and the lady really helped us in framing it, in going into some usable use cases and tackle one of them. We focused most on that. We also got the support of Philab, not exactly Nicola, but we'll look at it afterwards, Gabriele Meoni. And he was also very, very pleased with the results we got. So thank you so much.
Thank you, Fabio. So now it's Atufa turn.
Hello everyone, I am Atufa Shirin, and today I'll be presenting on behalf of my team the project AI Quality Assurance on Label Data. We use AI every day to get quicker responses and often struggle with getting accurate responses. For instance, I once asked, where is the Colosseum located? And the AI responded, it's in Paris. I mean, for the people sitting here, we know it's in Colosseum, but for someone looking at this information for the first time, they might get fooled. This is a simple example of hallucination, and hallucinations can occur, hallucinations can erode users' trust on AI. Today, there are many applications powered with LLMs in every sector, from customer support automation to blog post generation. And at one point or another, they will face hallucinations. As Marco mentioned, Lara, the most powerful translation tool, is also powered with LLMs and provides responses with confidence. Even for Lara to provide responses with confidence, it needs to go through hallucination mitigation process. So how can we mitigate hallucinations? One key way is to improve the data quality, the training data quality. And how do we get the high quality label data? Translated, the sponsor for our project is working on a tool, annotation tool, Hula Hoop, that provides high quality data, which leads to accurate LLM responses. They do this with the help of annotators, as we discussed during the fireside chat. So they do this with domain expert annotators. But we know that human involvement is prone to introducing human bias or errors. In fact, plus it takes time to get these annotations done. So it would have been better if we perform quality check on these annotations, right? In fact, much better if we automate this quality check. Therefore, we proposed an AI quality assurance framework that provides quality assurance or trustworthiness on the data. Our framework focuses on two dimensions of trustworthiness: the fact-checking and the guideline alignment. If you ask me why fact-checking, let's say your data was taken from a conversation which says Colosseum is in Paris, but we know it isn't. So we reduce the hallucinations, which can lead to responses that can make claims from unverified sources with fact-checking. The second dimension of our framework is guideline alignment. And we perform guideline alignment because we want the data to be in the format that the business requirement needs, but that the business requirement is. And so we remove any data which can lead to hallucinations, which could result in unexpected formats. So for the technical people in our audience, our solution for both the tasks involved extensive literature review, and for the fact-checking, our solution adapted to the chain of verification paper. This was a recent paper by Meta AI. And for guideline alignment, our solution has a solution. For a solution, in the final solution, we took reference of continual in-context learning approach, and we extended it to improve our guideline alignment responses. Our baseline for both the tasks was GPT-4o, but we leveraged open source models to retain the client privacy of the client data and achieve the benchmark results. We spent the first 3 weeks on fact-checking, and we achieved the benchmark results and, in fact, improved them, surpassed it. The rest of the week we spent on guideline alignment, and we achieved the benchmark results. The outcome of our project is increase in data quality in less time, reduction in the costs, and reducing hallucinations. Additionally, our project does not provide, is not only for any language, but for multiple languages, and can be applied to any domain. I worked on this project with Samir, who is sitting in the audience. And I am a machine learning engineer who has experience working on different domains, applying ML in different domains. If you are curious about any technical details, please reach out to us in the networking session. Thank you.
Thank you, people. Thank you so much. Now, I'm looking for okay, maybe Emanuele first. Maybe you can, share some comments. Emanuele was the coach of this challenge, so.
Thank you. Thank you, Cristiano. Actually, Cristiano was the coach with me, but here I am. So I just want to spend a few words highlighting the work of the team. I think, the key point is to understand, starting from the business problem, how to address the technical problems behind it. And I think the team did a great job to bridge the gap between the business and technical needs. Also, in my opinion, find one of the best solutions for this challenge. So I really want to thank them for the dedication and the quality of their work. So I was very quick, and I leave the floor to, I don't know, Alessio is there. He's from Translated.
Daniel, is your turn.
Okay, so good evening, everybody. I'm Daniel, and I'm going to present the last challenge of the day. So before starting, I must tell you that our stakeholder really cared about keeping a competitive edge over their competitors. So they asked us not to talk about the actual problem. So the problem I'm going to tell you about tonight is just a proxy problem that still explains well the actual things we have done. But keep in mind that this is fictional, it's not our actual problem. Yes. So we are talking about AI for a talent agency business. So picture a talent agency. What happens is that we have multiple talents. Think about singers, soccer players, influencers, all kinds of influential people. And the talent agency connects these talents with brands. Think about clothing brands or energy drink brands, Nike, Adidas, you name it. And they make deals between the talents and the brands. Okay? So if we can help a talent agency at all, we can help them in two ways. We can help them spending less time designing the deals, or being more successful at completing successful deals. Signing more contracts. Let's say that this company, this talent agency, has a team of 4 people, and they produce 1 contract per week. And out of all the contracts, out of all the deal they propose, 65% of them are successful. When we bring AI into the equation, what we want to do is we want to improve these metrics. And actually, if it took them 1 week to produce a contract, the team of 4 people, now they can do it in 4 days. And actually, in the time that they will only produce 1 contract, they can now produce 3 contracts. And if the successful rate of the deals was 65%, AI can push it to 85%. And the way we do this is very simple. We built 2 AI agents. So we have an AI writer and an AI judge. And the way the company works with these 2 agents is by first putting the deal details into the AI writer, which then produces a draft of the deal. Then the AI judge can help judging the deals, and especially giving criticism about it. Because if you have a deal draft and you want to improve it, you really care about the bad things about them. You do not need to know that something is very good. You can't improve if I tell you you're good. So this loop can go on as long as we want, and of course there are still humans in the loop, so it's not completely AI. Humans are still helping improving based on the AI outcome. But this is the way the company actually integrates AI into their workflow. In generating these deals, we have constraints and requirements, of course, because contracts are legal artifacts, and we need to agree with legal requirements when writing the contracts. And also, we have the deal requirements. So maybe the clothing brand wants the soccer player to wear their clothes for like 3 years or something. So that's something, that's a constraint. And also we have different talent profiles of different influencers with different audiences and different communication style, and we want to match them correctly with the right brands. We don't want to make deals that don't make sense. The way we solve this, the way we do this is by putting inside the brains of the model, as we can think of, both the general rules that govern all these contracts kind of world, so all the legal stuff, all the past deals of the company, so the model learns how they operate, and also all the talent profiles that the company is managing. Okay, so for the tech people in the room, what we do is we attack these contracts section by section, and in generating each section, we augment the prompt we give to the large language models with chunks retrieved from a vector database that has all that data, which is relevant to that subsection. So each subsection, so like the large language model that's working on one subsection, has all the context it needs to process that subsection. And the way the company interacts with this AI is via a web interface, and this is what it looks like. It's very simple. It has a sidebar with all the jobs, and then it has a work area where the company actually puts the data in. It has rider mode and judge mode, as I was showing previously. And yeah, when you start a job, like these jobs are very heavy, so they take a little bit of time. When you start one, you will see it in the sidebar with the progress. So you can even like close the tab and go grab a coffee, and as soon as it's ready, it will be there. And yeah, I think that's pretty much it for our challenge. And working on this challenge, it was me, then Giovanni, who is actually here, and Ayat, who unfortunately couldn't make it to Rome because of visa problems. So if Ayat is looking at the registration, hi Ayat. And yeah, I guess I will now leave the stage to our mentor, Vijay, that will tell you more about the challenge.
I don't think this. Okay, thank you, Daniel. That was a wonderful presentation. Life of an engineer nowadays, especially in machine learning, is quite strange. It's like, you know those elevators in airports where you have to walk? If you don't, you're pushed back. So we kind of have to keep walking just to stay in the same place. And that's how School of AI is. So one of the most interesting situations we encounter quite regularly here is sponsors coming to us saying, we have data, we don't have a problem to solve, but we want to use AI, and you need to tell us what problem to solve. And then there is LLMs. So nowadays, the complexity of problems people want to solve went from here to here. And we're still walking, trying to figure out how the technology works. So one of the most interesting things we did as a part of this challenge as well, and they did it fabulously, was to manage to get on calls with our sponsor to get them to give us the data that we need to solve their problem. And so it was less about writing the code, that was the easy part. More was about telling them, okay, we need data in this format and feedback from you in a different format. And that says a lot about the challenges these days. So I think I would say congratulations to the team on not just the engineering, but also the communication part, which is what a lot of good engineering is also about, and something I realized after being a part of School of AI. So yeah, And I would also give a special mention to our second coach, Carlo Meta, whose contribution was also quite instrumental to getting this challenge to the stage that it is now. Thank you. Now, back to Cristiano.
So thank you to really everybody, to all the fellows, coaches, mentors, sponsor. I think we are close to, you see, completing our pitch day, and now we will basically start the ceremony for the diploma. Okay, so maybe I can leave you the microphone. Yeah, thank you.
I think that the fellows really deserve their diplomas. What do you think? Congratulations. As you have understood, all the projects we've worked on are very tailored. So I invite you to come and talk to us. It's always a new adventure each time we have a new client that approaches us. So congratulations to all the team. I think they did wonderfully, especially also presenting. So I want to call Sandek. Congratulations. You stay here. You stay here. Yeah. Cristiana. That was fantastic. Mario. Mario? Mario Dani.
Exactly. Thank you.
Stay here. Samir? Prakar. Prakar, it's his second time. He likes it a lot. Giovanni? Congratulations. Atufa. Congratulations.